Okay, so in this video we're going to have a look at working out the averages from a histogram. Now in this video we're going to look at finding an estimate for the median, we're going to have a look at the quartiles, and we're also going to have a look at finding a mean. So there's quite a lot going on in this video due to the nature of this as well. It's quite tricky in order for you to obviously draw these, but at each stage of the way I'll do a little pause so that you can follow along. So with that being said, let's get started. Okay, so on to our first question. Now obviously you need to know how to draw and interpret a histogram. So if you haven't seen the video on that already, or you're not sure on how to do that, then I would go and watch that one first, and again that's going to be linked in the description. But for this first question we're going to focus on finding an estimate for the median. Now for this question we are actually going to draw the histogram. So again, if you are confident at drawing a histogram, you can always skip forward and I'll chapter the video for you so you can skip forward to the point where we find the median. But in order to draw the histogram we need to remember that we have to plot the frequency density. Now this is a particularly nasty one because the frequency density and the scale has not been done for us, so we're going to have to do that ourselves. But that's not particularly difficult here in our formula, and again I am going to assume that you know the frequency density formula on this because you've seen the past video. But in order to work out the frequency density we do the frequency divided by the class width. Now whenever I do this I always label the class widths first. So for that first one there of 90 to 100, that has a class width of 10. And you can always feel free just to label that somewhere near your table, and then the next one will have a class width of 5, then we've got another class width of 5, we've got a class width of 10 and a final class width of 20. Now of course a lot of these questions are calculator based, so we are going to be using a calculator here, and the formula that we're going to use is frequency density is equal to the frequency divided by the class width. So again, at this point, if you want to pause the video and have a go at this question, please feel free to do so, but otherwise follow along as this is going to be mainly an instructional video. So for the frequency density, we're going to label it to the side. The frequency is 13, and if we divide that by 10, we get a frequency density of 1.3. For the next one, it's 16. If we do 16 and we divide it by the class width of 5, we get a frequency density of 3.2. On to the next one, we have 18. 18 divided by 5 is going to be 3.6. So that's our next frequency density. We've got 22 divided by 10, which is 2.2. And for the last one, we have 12 divided by 20. And 12 divided by 20 comes out as 0.6. So all we need to do now is we need to draw our histogram. So first things first, we need to plot the scale down the bottom. And you can see that the speed starts at 90, just up there, and it goes up to 140. So we can plot this in maybe in tens. If that was 90, then we could go along, this would be 100, just here. If I can actually get that to put a mark in, make it nice and clear. We'll put this one as 110, 120, 130 here, and 140 right at the end. So there we go, we need to label that up, 90, 100, 110, 120, 130, and 140. Now of course whenever it comes to a histogram you need to label your axes. I'm not going to be able to fit that in underneath as I've tried to make the graph as big as possible here, so I'm just going to put it to the side, and that is a speed, and we should put that's in kilometers per hour. Now up the other side we're going to do frequency density. So before you do that you just want to identify where your biggest number is. So 3.6 is our biggest frequency density, so we need to probably go up to 4. So if I was to have this as 1, obviously starting down here at 0, that would make this one 2, 3 and 4. So that looks fine. We could probably scale that a little bit bigger, but that is going to be absolutely fine. So 1, 2, 3, 4. Okay, so moving on to the next part, we just need to draw it in. So for the first one, we have a speed that goes from 90 to 100, and that has a frequency density of 1.3. So go along to your 100, scale that up to 1.3, obviously using a ruler and a pencil, and draw in your first bar. For the next bit, we can find the next one, which is 3.2. That has a width of 5. So we go up to 3.2, just past the 3, 2 little squares there, paying attention to the scale, and there's your second bar. The next one's 3.6, that goes up to 110, so we'll go up 3.6 is just past halfway by 1 square. And there we go, is our next one. The next one's 2.2. So I'm just going to obviously use a ruler here, go across, and this has a width of 10, so this goes to 120. I do have to draw that again. So it's 2.2, goes across to there, and then down to 120. And the next one has a width of 20, and only has a frequency density of 0.6, so just above 0.5 there by 1 square. And there we go, that's our histogram drawn. So obviously that's a nice little reminder for you on how to draw a histogram. Of course, we need to label our axes over here. We need to label that as the frequency density. There we go, so I'll just put frequency density there, and then we just need to find our median. Now when it comes to finding a median, you can either do this from the graph or you can do it from the table. Now personally I would do it from the table, because if we look at the table it just collects all our numbers nice and easily. And in order to find the median, we take our normal statistical approach, which is to add up the frequency. And if we add those up, they add up to 80. And when we are finding where the middle number is, you add 1 and divide by 2. So if we add 1 to 80, let's have a look. 80 plus 1 is equal to 81. If we divide that by 2, we get 40.5. Let's actually write the correct number there, 40.5. Now when we're looking at 40.5, that is the 40.5th number. So that's not our median, but that's where our median lies. It's the 40.5th number. And if we go ahead and look at the table, we need to just count down the table and figure out where that is. So to make this a little bit easier, I'm going to get rid of some of our working there. Obviously always leave your working out, but just so you can see this a little bit clearer, we'll get rid of all of this, and then we will just have a look at finding the median. So I've got rid of that to the side because it's just going to be a little bit easier to count. And if we count down the table, at this point we've got up to the 13th. If we add the 16 to that, we're now at the 29th person. And if we add 18 to that, that would get us to 46. So sorry, that's not going to be 46, is it? That's not very good. If we add 18 to that, it gets us to 47. So looking at our table there, the 40.5th person is going to be in that third row there. So it's going to be somewhere in here. And we need to find out where that person is. So in terms of how far into that row, well, if we had 29 on the row before, to get to the 40.5th person, that would be an additional, and let's just think, 40.5 take away 29 would be an additional 11.5 people. So that would be plus 11.5. So we want to find out where that 11.5th person lies, and we can do this as a fraction. So if we get rid of that 47 there, because we don't really need that, we just know that that 40.5th person is going to be there. So what's that going to be as a fraction? Well, we could think about this to the side. So 11.5 people out of the 18, or it might not necessarily be people here because I haven't actually given you the story behind this question, but it's about speed, so let's just assume that it's cars. So this is going to be the 11.5th out of 18 cars. And if we work that out and just type that in on a calculator, let's just see what we get. Probably not going to be a very nice number there, but if I do 11.5 divided by 18, it comes out as 0.638, and we have a recurring dot above the 8. Now that right there is the percentage into that particular portion of that row. So if we were to turn that into a percentage, it'd be 63.8%, or 63.8 recurring percent. So we want to work out, as a percentage of the width, how far in is that 63.8 recurring percent. Now looking at that particular width, it goes from 105 to 110. So that has a width of 5. So if we want to go 63.8 recurring percent into that, then we can just take that decimal and multiply it by 5. So if we do that, and we'll do this again to the side, and we're running out of space a little bit, so we'll get rid of some of this working out here again. Let's get rid of that. That's how we found the median. So 5, the width, multiplied by 0.638 recurring. Let's just type that in on the calculator. That comes out as 3.194 recurring. So 3.194 recurring. So that is how far into that width of 5 we need to go. And as you can see, there's quite a lot of working out here, which is why this is a high graded topic. But if we have to go 3.194 recurring into that particular class, which starts at 105, then we just need to add that on to 105, and that will be where our median lies. So if we add that on to finish it off, let's just do it over here. So 105 plus 3.194 recurring, we get a final answer of 108.194 recurring. There we go, and that is in kilometres per hour. So that would be our final answer, 108.194. It doesn't say in this question how to round it. It would be appropriate to round it to maybe 108.2 potentially kilometres per hour, but that is absolutely fine to leave your answer in its exact value there, 108.194 recurring. But again, you could round your answer to particular ranges. You could even say 108, and you might get a slightly different answer if you do it from the graph and use a graphical method. But it's much easier to do it from the table there, even though obviously that doesn't look very easy. It is a difficult topic. But just running through what we did, we added up the total frequency, which was 80 people, to find the middle, add 1 and halve it, so 40.5. We counted down the rows to figure out that the 40.5th person laid in the third row, which is the 105 to 110. That went 11.5 into that row. So the 11.5 over 18 gave us our percentage, or our decimal version of the percentage, which is 0.638 recurring. So we found out the percentage of the width, so that percentage of 5, which was just down here. So 5 times that decimal. That gave us the 3.194, and that's how far into that width we had to go. So we added it to 105 in our final step, and that gave us 108.194 recurring. So there we go. Right. Quite a lot to go through for estimating the median from a histogram. Certainly not an easy question, but hopefully that there gave you a method for how to go about working this out. Okay, let's have a look at another question. Okay, so this question says find an estimate for the lower quartile. This particular question needs us to actually interpret the histogram, so we need to find the frequencies ourselves. Again, I've covered that on drawing and interpreting histograms, which again is linked in the description. But if you want to have a go at this question, pause the video, have a go, see if you can work it out, and we'll go over the answer. Okay, so having a look at this then, we first need to find the frequencies. Now the first one's been done for us, and you can see that from 0 to 5, it has a height of 0.8 just here. And that's how they've got the frequency of 4. If we reverse our formula to find the frequency, you have to do the class width multiplied by the frequency density. So the frequency density multiplied by the class width. So if we go about working that out, and you can see that's how they've got 4, because 0.8 times 5 is equal to 4. And we just need to do the same with the others. So for the next bar there, and again, if we just highlight this one just here, that has a width of 10, and it has a height of 0.4. So 0.4, and we'll just do the working out here for the moment, 0.4 times 10 gives us a frequency of 4 as well. Moving on to the next bar, if we have a look, we've got this one just here. That again has a width of 10 and it has a height of 0.6. So 0.6 times 10 is equal to 6. There's our next frequency. On for the next one, we've got a width of 5 and a height of 1. So we've just got 5 times 1 or 1 times 5, which gives us a frequency of 5. And for the final one, we have, let's just get rid of that one there. For the final bar just here, we have a width from 30 to 50, which is a width of 20, and that has a height of 0.2. So 0.2 multiplied by 20, that comes out as 4. So there we go, we've got all of our frequencies. Now we can get rid of that working there because we're going to need some of that space. If we get rid of that, that just leaves us with our frequencies. Now we're going to treat this in a very similar way to we did on our last question, except we're not finding the median this time, we're finding the lower quartile. So if we add all of these together, we get 8 plus 6 is 14, plus the 5 is 19, plus the 4 is 23. So we have 23 numbers in our, or 23 people, whatever it's about, in our histogram, in our chart. Now this one is about the time taken to do something, but whatever the story's about, we'll take exactly the same method. Again, we're going to add 1. Okay, so to find the median, we added 1, and then we divided by 2. To find a quartile, we add 1, but we're going to divide by 4. So 23 plus 1 is equal to 24, divided by 4 is 6, which is not the quartile, but it's where the quartile lies. It's the 6th number down in our table. So if we look at our table, which starts with 4, and then we add the other 4, and it gets to 8. So that 6th number is going to be in that second row this time. So it's going to be just in here. So we're going to find how far it goes into the row. We're going to find the proportion into that row it is, or that percentage that we found last time. And we're going to find that percentage of the width of that particular class. So to get from 4 to the 6th, we're going to have to add 2. So it's 2 into that row. Now 2 out of 4 is going to be our fraction, or give us our percentage. So if we have a look at this one here, we're going to have 2 out of 4 into that row. 2 out of 4 is equal to 0.5. So that is going to be 50% into that particular row. Now if we have a look at the width of that row, it goes from 5 to 15, and that is a width of 10. So if we're going to go a width of 10 into there, that is going to be 50% of 10, which is nice and easy to work out, but we can bring this just down to here. There we go. So it has a width of 10. So 10 multiplied by the 0.5, or 50% of 10, is equal to 5. So that's how far into that class it's going to be. So to finish this off, we would just take the start of that class, which is 5, add 5, and that is equal to 10. So there we go. Our lower quartile is going to be equal to 10. And if we think about where that is, you could think it's just here somewhere. There we go, it's just in the histogram, and that's where our lower quartile is. So there we go, that's how you go about working out a lower quartile. That was obviously much nicer than the previous one, as we got nice whole numbers. Technically, you could probably even do that one without a calculator. So that could be a calculator or a non-calculator question. It would be pretty nasty on a non-calculator question, but none of the calculations there were too bad. Finding 0.5 of a number just halves it, so that wasn't too bad. 2 divided by 4 is 0.5, that wasn't too bad either, and even those frequencies weren't too bad at the start when we were working those out. So there we go, as you can see, a very similar method. We added up the total and got our 23. We then found out that the 6th number was our lower quartile, so adding 1 and dividing by 4. We then found out what fraction of that it went into that row. So that was 2 that we had to go into the 4, so 2 out of 4, which was 50% of the way in. And then we worked out 50% of the width, which came out as 5, and finished our question by adding it onto the start of the width, so the start of the class. So 5 add the 5, but gave us 10 for our lower quartile. So there we go, that is another one of our questions, and now we're going to have a look at our final question. Okay, so looking at our final question, and it is finding the mean from a histogram. Now the good thing about finding the mean from a histogram is it's pretty much the same as finding the mean from a group frequency table, except of course we need to get all the data from our histogram. So it says here the histogram gives the information about the stopping distance of 80 cars in a brake test. Calculate an estimate for the mean distance. So of course, as the same with group frequency, we can only find an estimate as we're going to have to use the midpoints. So we're going to start by drawing a little table that looks like a group frequency table. Now rather than writing all of the inequalities here, I'm just going to write it as our numbers, where it goes to and from, just as we only want it to find the median. And it's just going to take up quite a lot of space if we draw in all of the inequalities. So for now, let's just draw this in. So the first bar down there goes from 6.4 to 7.2. So that is from 6.4 to 7.2, and we want to find the frequency. So to get the frequency, we're going to use the same formula we have before, and that is that the frequency is equal to the frequency density multiplied by the class width. So again, let's just have a look. We have our class width there, which goes from 6.4 and it goes to 7.2. So that is a class width of 0.8. So we're going to do 0.8 for our class width and multiply it by the frequency density, which we can read from the histogram here, and that is 10. So that gives us a frequency of 8. So 8 is equal to 0.8 times 10. On to our next one, we have 7.2. And that goes up to 7.6. So that is a class width there of 0.4. So that's going to be 0.4, and we're going to multiply it by the frequency density, which we can read again just here, and that is 50. So again, just working that out on the calculator, 0.4 times 50 comes out as a frequency of 20. And again, you can label these inside the bars if you want. That is 8, and that one's 20. On to the next one. This goes from 7.6 over to 8.0. So that is a class width of 0.4. So 0.4 multiplied by the frequency density, which we can get over here, which is 100. And that gives us a frequency of 40. And on to our final one, it goes from 8.0 over to, just down the bottom there, it's between 8 and 8.4, so that goes over to 8.2. So that is a class width of 0.2. So this is going to be 0.2 multiplied by the frequency density, which if we trace it all the way across is a frequency density of 60. So 0.2 times 60 gives us a final answer for our frequency of 12. So now we have all of our frequencies, we can think about estimating the mean. So we'll get rid of some of this information, we'll label this onto the diagram as well, you don't necessarily need to, but we'll put that on there so you can see those frequencies. So thinking about how we would approach this from a group frequency table, again if you're not entirely sure you can check it out in my video in the description, but we'll get rid of this working because now we're going to work out the totals. So first things first, we'll get the total frequency. So if we add these up, that adds up to 20, 40, 80, so we have a total frequency of 80. But in order to work this out, we need to actually get our totals by multiplying the midpoint by the frequency, just as you would in a group frequency table. So the midpoint of 6.4 to 7.2, again you can add them together and divide it by 2 if you want, but the midpoint there is 6.8. And you can write this in if you need to, but 6.8, and we're going to multiply that by the frequency, and 6.8, just doing this on the calculator, multiplied by 8, gives us a total there of 54.4. On to the next one, our midpoint there is 7.4, so we're going to do 7.4 and multiply it by 20. I'm going to repeat this process for all of them, so let's put that time sign in. We're going to work out all of these totals. So for 7.4 multiplied by 20, that gives us a total of 148. On to the next one, our midpoint there is 7.8, so we'll do 7.8 multiplied by 40, and that gives us a total of 312. And on to our final one, which has a midpoint of 8.1, so 8.1 multiplied by 12, and that gives us a total of 97.2. So 97.2 is our final total. So if we add these all together, let's have a look. We've got 97.2 plus 312 plus 148 plus 54.4, and that gives us an overall total of 611.6. So exactly the same calculation that we would do from a group frequency table, we're going to take the overall total, 611.6, and divide it by the total frequency of 80. So if we just write this to the side, 611.6 divided by 80, we'll type that in on the calculator, so dividing our answer by 80, and it gives us a final answer of 7.645, and that is our value for our estimated mean. So there we go. As you can see, that is not necessarily harder. I think actually probably the hardest out of all of these was finding the median, and that was our first question, just because we didn't have some very nice numbers, and finding the median is just a little bit trickier than necessarily finding the mean. Of course, this one had the most working out, as we had to find the frequency of all the bars. Then once we had all the frequency, and we then obviously found all the totals using the midpoints. So it was a very long process, this question, definitely a difficult one. But again, if you were struggling with any of those elements, I do recommend that you go and have a look at the video on histograms and interpreting histograms, and also the video on finding averages from a grouped frequency table. So I hope that video was useful and helpful. If it was, please like, please comment, please subscribe, and I will see you for the next lesson.